Hello, my name is Paul Richardson, and today I'm going to be discussing the importance of recognizing helicopter aircraft parts, and in particular safety critical parts. Similar parts exist in America and Europe, but for today our focus will be more towards the European aspects of these components. So, what is special about safety critical parts? Identifying these parts from normal components is a requirement from design to manufacture to operational use and maintenance. The original certification of the aircraft depends crucially on these safety critical parts maintaining their critical characteristics throughout their life. This also includes their transportation. Similar definitions of these parts all have the same meaning. Flight safety parts, critical parts, vital parts, and identifiable parts all mean the same thing. Typical safety critical parts would be flight controls, gearboxes and drive shafts, main and tail rotor components, and windscreens. There are many more. The designs of helicopters have many critical single path loads. A failure of any one of these could be catastrophic. These parts are assessed during design and components are thoroughly tested to ensure their design meets airworthiness requirements. Safety critical parts have critical characteristics which do not tolerate variation from original design requirements. For example, part dimensions or tolerances, surface finishes, material specifications, and inspection processes. It is very important to remember that non-conforming critical parts can fail. So, who needs to know about safety critical parts? Well, the company Part M organisation, which includes fleet support, needs to ensure that these parts are managed or controlled correctly. The maintenance organisation must be made aware of the specific inspection or handling requirements from the manufacturer or the designer's instructions. The training organisation also needs to emphasise safety critical parts in their instruction courses for each aircraft type. Finally, the supply chain should ensure that the transportation and storage of safety critical parts meets manufacturer's specifications. The regulations for the design of aircraft in Europe are either CS27 or CS29 depending on the weight category of the aircraft. In a similar manner, the regulations for this in the USA are AC27 and AC29. These rules ensure that safety critical parts are identified at the earliest opportunity to ensure that they maintain their integrity, and in simple terms, that they don't fail prematurely. Part of the documentation issued when buying any aircraft from a manufacturer are the ICA, or Instructions for Continued Airworthiness. Using this information allows our maintenance planners and Part M to recognise where safety critical parts need special attention or inspections and to call these up in our documentation. Components installed on helicopters must be identified by manufacturers as critical parts because their potential failure would have a direct effect on the aircraft's integrity, and therefore these parts must be controlled. Critical parts may have special transportation, handling and storage techniques, and modifications we embody on aircraft similarly arrive with an ICA document for the same reason. Repairs or adjustment to safety critical components may only be carried out under manufacturer's instruction. Any illegal modifications could have hazardous consequences. Here is an example of a safety critical part that failed due to fatigue cracking caused by corrosion pitting. A tail rotor drive shaft from a Bell 206 helicopter. For engineers, special tooling or techniques may be needed when installing safety critical parts. Service life recording of safety critical parts must be accurately recorded. Unusual wear patterns or deterioration of safety critical parts must be reported to the manufacturer. Use the BSafe Maintenance Safety Report for this. The Leonardo AW189 and 139 Aircraft Maintenance Manual shows critical parts listed in Chapter 00-60, where these parts are listed by ATA chapter number. On Leonardo aircraft, if a safety critical part is replaced at retirement life, the associated hardware must also be replaced. That's the nuts, bolts and washers. The AW189 and AW139 Aircraft Maintenance Manual, available online, shows critical parts using task splash screens to alert you, like this. Note the yellow and black edging. Red and black edging splash screens are usually used for chemical or safety precautions. The splash screen will only be removed if you click the Acknowledge button. The Sikorsky S92A has a different technique to highlight safety critical parts. The S92 Airworthiness Limitations ATA Chapter 04 shows safety critical parts listed and identified using notes. Note 13 highlights this. Sikorsky also shows critical steps and critical parts in the maintenance manuals. The black CS and star symbol highlight the critical step, and the adjacent warning highlights the critical parts. By definition, the software we install is an aircraft component part and therefore must be accompanied with a Form 1. The software part number must meet Part 21 Subpart Q requirements, and usually this means the marking on the container or the CD-ROM will show a relevant part number. Software should only be authorized for installation by Part M instructions. Logbook entries must be created to record field loadable software status changes, which is recorded by Tech Records. Additional parts that you may encounter are EPA, European Parts Approval, which originate from Europe, and PMA parts, Parts Manufacturer Approval, which come from the USA. European Parts Approval components that have EPA marks on them, along with the manufacturer's name or trademark, and the part number. EPA parts are marked this way to identify that they are not parts from the type certificate holder, so clearly to identify they're not original parts. You can see that this example is manufactured by ACK Aviation. EPA parts may be repair items or manufactured spares or interior trim parts, for example. EPA parts are approved by either a Part 21J or a Part 21G organisation. EPA parts are marked this way to identify that they're not parts from the type certificate holder, that's the manufacturer, so clearly identify that they're not original parts. EPA parts may be repair items or manufactured spares or interior trim parts, for example. EPA parts are approved by either a Part 21J or a Part 21G organisation. Parts Manufacturer Approval, or PMA parts, originate in the USA and show the letters FAA-PMA printed on them. PMA means that the part manufacturer is approved, not that the individual part itself is formally approved, although it should meet specifications. The PMA part manufacturer will have passed the same design test procedures as the original manufacturer. PMA parts are often approved for use under EASA manufacturers commonly produce parts under the PMA route. For example, this might be Honeywell or Hamilton Sundstrand, who make autopilot systems. Airbus Helicopters USA also produce PMA parts, along with Safran, Sagem and Sikorsky, and there are many others. A wide variety of parts can be PMA parts. Some aircraft manufacturers are unhappy at the use of PMA parts, and using these parts could affect power-by-the-hour agreements or similar maintenance warranty contracts. Produced under licensing agreement from the FAA design approval holder may be written in the Remarks Block 12 of the FAA Form 8130-3 for licensed PMA parts. A declaration must state that the part must not be a critical component. This PMA part is not a critical component will be written in the Remarks Block 12 of the FAA Form 8130-3. So the Form 8130-3 information is vital when accepting the component. More guidance in the EASA Technical Implementation Procedures, the TIP agreement, between EASA and the FAA can be found. Usually, European aircraft component parts are manufactured within a Part 21 Subpart G organisation. The Part 145 regulation for aircraft maintenance does permit certain parts fabrication, but this is strictly controlled and intended for a one-off event or a single aircraft. These manufactured items cannot be issued with a Form 1 and therefore cannot enter the supply chain. These parts may be fabricated usually under Part 21 Subpart J supervision and control. These are the designers. Usually these parts are created by engineers adjacent to the aircraft, which is intended to be the recipient of the part. These items can only apply to one aircraft and cannot be made in quantity batch format or sold to other companies. Often they may be sheet metal repair schemes, for example. Unapproved parts, and that's also known as bogus parts, includes counterfeit parts, stolen parts, production overruns sold without authorization, life-limited parts which have exceeded their life limits, or approved parts improperly returned to service, and that could be from a crashed aircraft. Fraudulently marked parts or parts which have no traceability are also unapproved or bogus. In America, the punishment for selling bogus parts ranges from a 10-year imprisonment and a fine of up to $250,000 to life imprisonment and $1 million for an individual and up to $20 million for a corporation. The unapproved bearing spacer on the right of this picture has no lipped edge, and the part details were hand engraved compared to the original on the left. Component data plates are also being forged. 2 of these are approved and the others are bogus, but which ones? Let's highlight the bogus parts. It is not just the parts that are being forged. Here are 2 component labels. The one on the right has a manufacturer's logo stamped incorrectly at 90 degrees. EASA has created a website for anyone to use in identifying suspect unapproved parts. That's SUP for short. Although it only started late in 2018, it already currently lists nearly 8,000 parts. It is easy to find on the internet. Just type in EASA SUP into Google to find the site. Parts also go into this list with forged Form 1 documentation. If you locate a part on the EASA SUP site, clicking for more information brings up the details for why it is listed. This example shows an engine part which was determined incomplete during manufacture. That's the end of our screencast. Thanks for spending some time with me today, and good luck with proceeding to the short test about this subject.